This is the Unit 1 quiz. So first one says, which of the following could be irrational? Select all that applies. So this one it says could, so that means that anything that might give us an irrational number, we want to pick. So deal with A. So for A, we have to do the sum of two rational numbers. We're adding two fractions, so we have to decide if we're going to get an irrational number. We're never going to get that, and we could show it if we do a whole proof out. We can do the proof that we saw in class. AB plus CD is going to be the same as A times D, B times D. So I can multiply both the top and the bottom by D. Likewise, to get a common denominator, I can multiply these both by B. And then when I add these up, whenever we add fractions, we keep the denominators the same. So this is going to stay as BD. And we just add the numerators. So AD plus CB. So again, that's the big proof of why we always end up with a fraction. Since we're always going to end up with a fraction when we add two fractions, it's not going to ever be irrational. So A can actually never be irrational. So a long explanation for that. But again, the idea is fraction plus a fraction, or rational number plus a rational number, is always going to be able to be written as a fraction or a rational number. For B, it says the product of two irrational numbers. So we got to be careful with this one because with B, I have to think of two irrational numbers. Everybody loves pi. So if I do pi times pi, we're going to get pi squared. And that's not really a normal number that we can write as a fraction. So that does work out. So pi times pi works out pretty well. We have to be careful. There are some that don't. So square root 2 times square root 2 is the square root of 4, but the square root of 4 is 2. So it's possible this one actually ends up being rational, but since we're doing could instead of must, this one is okay because that one does work. C says the sum of a rational number and an irrational number. We saw this one in class. If we tried to do like square root of 7 plus 0, I guess we'll do it backwards to stay in the same order of the English. Because 0 is a rational number, we said. Square root 7 is irrational, and we get square root 7, we get an irrational number back. So that's good. And this one, in fact, it'll always work out, will always. So not only could it be, it must be. There's no way to get a non-irrational number. And then the product of a rational number and a rational number. So it shouldn't be an ed. So if we multiply two fractions together, again, we saw this one in class as well. So A over B times C over D. When we multiply the fractions, we just multiply straight A across. So AC, BD. So this one will never give us an irrational because we're always going to get a fraction back. So remember, this is going to be a fraction times a fraction, gives us a fraction back. So that's number one. A little bit of theory work. For number two, which elements in set A are in both sets B and C shown below? So if I look at set B, all the odd numbers, I'm just going to grab all the odd numbers from this set. So it's going to be -3 is odd, 5 is odd, 13 is odd, 15 is odd, 19 is odd, and 43 is odd. Then I'm going to grab the multiples of 5. So set C is the multiples of 5. So my multiples of 5 are -10, 5, 15, and 20. And what we want to do is find things that are in both. So I'm going to look and see -10 is not, -3 is not, 5 is, I see a couple 5s. So 5 is going to be one of my answers. 13 is not, 15 is in both. 20, 19, and 43. So it's just going to be these two. And again, there's a lot of different ways that you could approach that one. So I did it just by showing out all the sets. If you want, I mean, you can just look at set A and decide, all right, if it's got to be a multiple of 5, you know it has to end in 5 or 0. If it's odd, that gets rid of everything that ends in 0. So I just need to pick out everything in set A that ends in 5. So that's how to do number 2. For 3, order the numbers from least to greatest. Probably easiest to turn these all into decimals, unless you're familiar with what some of these ones are. So 10/3, again, if we want, we can throw that in to Desmos right here and do 10 divided by 3 to get 3.3 repeating. So throw that in as a decimal is 3.3 repeating is 10/3. Square root of 10. Let's figure out what square root of 10 is. So SQRT of 10, 3.16227. So 3.162. Might seem like I'm doing a lot of decimals on that one. But pi is kind of close to that, so I want to make sure I'm picking the right thing. Pi, 3.1415, so on and so forth. Again, dot, 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 dot. I should have that because these do kind of keep going on. This will keep going on. And in case you don't have pi memorized, that's okay. Desmos itself lets you do pi. If you bring up the on-screen one, you can just press the pi button right here. Same deal. This is where the square root is down here. You don't have to type SQRT, but it's kind of cool. You can actually just type pi, Pi, and it'll just pop up. So that's what we got for pi. And then the last one is just a straight decimal. Oops, 3.5. Obviously, that's 3.5. So what we want to do is we want to go from least to greatest. So the smallest one is actually going to be pi because 3.14 is less than 3.16. So pi is the smallest. Next up would be the 3.16 for square root 10. And we get 3.33 for 10 thirds. And then we get 3.5 for 3.5. Again, I have to report my answer the same way that it was given to me. So I couldn't write the decimals and just claim that that's the answer. I do need to actually put the numbers in order from least to greatest. So that's what we got. So there we go. Nice. So for number 3, which of the following results in a rational number? Select all that apply. So the nice thing is we could just throw these all in the calculator if we really want to. This one's not going to work out because this is a rational plus an irrational, which is always going to be an irrational, so I'm not going to pick A. For B, I got 5 over 6 minus 36 over 3. This is a rational. It looks like this one's irrational, but we got to be careful. Believe it or not, that's a rational number. The reason why, if we type it in, we got 5/6. We've got square root of 36, which now you can see why. Square root of 36 is just 6. That's really just like a different way to write the number 6 right here, over 3. It's 2, so if I do 5/6 minus 2, looks kind of weird, but I do have the fraction button, and it does make a fraction. We could write it as a fraction. We could write it as negative 7/6. So we actually do want to pick that one because a rational minus a rational is always going to be a rational. With C, this is going to be a rational times an irrational. We said as long as the rational number is not 0, it's always going to be irrational. So we're not going to pick that one. And again, square root 36, we got to be careful. This is really a rational divided by a rational. Rational divided by a rational is always going to be rational. Again, the thing that we look out for is those square roots. We just saw the square root of 36. I'm going to show you square root 12 just to show that square root of 12 is irrational. And in decimals, it's kind of nice. You can even see there's no, you can't see my finger, but there's no little fraction over on the right of this because you can't turn this one into a fraction. So Desmos is helping you out a little bit if you want the help. All right. So then we're going to move on to number 5. So those first 4 all come from the first section. So number 5, now we're going to do some equations. So we're going to solve this equation out. So 2 ways to approach it. So method number 1 is we could just distribute everything. So we distribute inside the parentheses. 5 times 3p is 15p. 5 times 10 is 50. 5, oh, I'm done. I'm out of parentheses. Everything else just kind of flows. Minus 5p equals negative 15. I can combine my like terms. 15p minus 5p is 10p. Minus 50 equals negative 15. And now I got to do numbers on one side, letters on the other. So I got the p is over here on this side. It's the only thing that's got p's in it. I have to move the numbers to the other side. We're trying to get the p by itself. We're trying to isolate that p. So we got 15 and 50 is 35 because that's negative plus positive. Then we need to divide both sides to get the p totally by itself. Always divide by the number on the variable. So since 10 is with the p, that's how I know I'm going to divide by 10. And we get p equals 3.5. Just to show, that's going to cancel. And in this step, those are going to cancel. So that's one way to do it. So we get 3.5. If you want to double check, you're welcome to double check, just like you did in 8th grade. Take 3.5, plug it in, and see if it works. I do want to show method 2. There is a second method. So for method number 2, what we're going to do is start back at the beginning. And instead of distribute, we're going to say, well, this is multiplying, and I'm allowed to divide everything if I want to. So if I want to divide everything by 5, I am allowed to do that. Might be a little bit of a strange step here, but those will cancel to 1. And I'll get 3p minus 10, because again, those canceled on this piece. 5p divided by 5 is just 1p, so I can just write p. And then negative 15 divided by 5 is negative 3. So that one was a little bit sneakier to see, but the reward is, look, my numbers are a lot smaller than they were over here. Now when I combine my like terms, 3p minus p, I have 2p minus 10 equals negative 3. So the reward there is all these numbers are a lot smaller. I'm going to add 10, but you can see now I'm keeping the colors the same. We're doing basically the same steps. 2p is 7. We'll divide both sides by 2, since that's the number that's on the p. And again, we're going to get p equals 3.5. I feel pretty confident with that since we got it 2 different ways. But again, you can plug it in the 3.5 for the p's up here to double check your answers like you did last year. All right. For 6, Darren wants a coupon for $4 off the lunch special at a restaurant for each of 5 days. He pays $75 for the 5 lunch specials. Write an equation to find the original price P of one lunch special. So again, we actually have to get the equation to get points, not just write down the answer. So remember in class, we talked a lot about how we got the answers, not just what the answers were. So this is why we want to develop our thinking and try and figure out how we can get to the original price P. So if we read it, we know he's going to have his lunch special, and he's going to get $4 off the lunch special. So he's not paying the full price P. He's going to lose $4 on that. He's got a discount. So instead of paying the full price, it's $4 less than the full price. And he's going to go for each of 5 days. So he's going to do that for 5 different days. And in total, he's going to pay $75 for all 5 of the lunch specials. So that's going to be our equation, and we're actually done with part A. So part A, we don't have to solve anything. We just need to get the equation. For part B, we do need to solve. And just like we did with the last question, with question 5, we could solve it either way. We can either distribute or we can divide. Personally, since we set it up and since we developed it like this, I'm thinking that maybe doing the division first is going to be a little easier. If I divide everything by 5, we'll get p minus 4. 75 divided by 5 is 15. We add 4 to both sides. We get p equals 19. Okay, all right. Let me double check, though. Let me try to do it the other way. If I distribute the 5 instead, I'm probably going to need a little bit more space, maybe. Maybe not. I'm going to get 5p minus 5 times 4 is 20 equals 75. I'm going to add 20 to both sides. 5p equals 95. And I'm going to divide both sides by 5. Again, that's 19 nickels in a dollar. Or 19 nickels is 95 cents. 20 nickels is a dollar. You're 1 nickel short. So P has to be 19. So again, I got the same thing 2 different ways. So I'm pretty happy that P is 19. And I'm going to go with 19 as my final answer. You don't have to do it both ways, but you may prefer one way to the other. So we can see that's another good equation question. All right, number 7, we did one just like these in class as well. The sum of 3 consecutive even integers is 78. Set up an equation to represent the situation. So we don't even need to get the numbers. That's just bonus if you can get the 3 numbers. The whole goal here is to make the equation. And we also talked in class about the 2 different ways to do this one. So one way to do it is we can make x the smallest number. So the next one would be, since they have to be even numbers, 2, and then 2 after that would be the next even number. And then I'm just going to say another even 2 more after that to get to the next even number. Because if we're counting evens, we're counting by 2s every time. Even if this said odd, I would still have the same equation here, because between 1 and 3 is 2 numbers. Between 1 and 5 is 2 to 4 numbers. We know it is 78, and that's it. We don't have to do anything else. We can stop right there. We have an equation that's valid, that works. You can simplify it a little bit if you want. So we could just do the quick simplify, which is just resolve the 2 plus 2. So x plus 4, and that looks a lot like something that we did in class. And we can even simplify it a little bit more like we did in class. We can say we've got 1, 2, 3 x's. 2 plus 4 is 6, and that still equals 78. So perfectly fine. We kind of looked at what we called a little bit more of an advanced method. So if we didn't want to make x the smallest number, if we want to make x the middle number, the one after that would be x plus 2, and the one before that would be x minus 2. Because again, if we're in the middle, the even numbers next to it would have to be on either end. So one of them is 2 greater, one of them is 2 less. This is equal to 78, and this would also be a correct answer. So you can see there's a lot of different ways to do these. Even though it seems like we're just solving equations, you have a lot of freedom in choice. And you can simplify this one as well. And remember, the reason we did this one is because the 2, negative 2 and the 2 would cancel out, and we get 3x equals 78. Also a correct answer. For the bonus, what are the 3 numbers? Again, this doesn't really matter too much because it's bonus, but it's always fun to figure them out. We know that 9 squared is 81. We're 3 away from that, so we should have 26 for x in this case. So if I'm solving from here, or I could just divide both sides by 3, I'll get 26, which means that 26 is in the middle. One higher would be 28, and one lower is 24, because remember, the numbers have to be even. So we're counting by 2s. And that's it for number 7. All right. All right. So now we're on to number 8. This is the last section. So now we're not answering what the solution is. We're answering how many solutions there are. So to figure out how many solutions there are, we still have to do some solving. So we're still going to try and simplify as much as we can. So I'm going to combine like terms over here. So 4y plus 2y is 6y. Over here, I do feel like distributing this is going to be easiest. I don't think I want to divide by negative 3 because then I would have a fraction over here. I don't think that that's going to help me out too much. So negative 3y plus 3 and then minus 1. Now at this point, I can already answer the question because again, the question is how many solutions? And since there's different numbers of y's on both sides, I'm already done. We already know there's only going to be one solution. So the answer is there's just one solution. Remember, if there's the same number of y's on both sides and the numbers are the same, then it's infinite. If there's the same number of y's or letters on or whatever the variable is on opposite sides, and the numbers are different, then there's no solution. Now, if you can't see that, that's fine. That's okay. We're going to keep going. So we're going to drill this down a little bit more. So I see I can combine like terms over here. So I combine like terms on that side with the y's. Here I can combine the numbers. 3 minus 1 is 2. And now I have to just do my regular equation solving. So I get y's on one side, numbers on the other. So we're going to go ahead and move. Since I don't like this negative over here, I think it's going to be easiest to add 3y to both sides. So that puts all the y's on one side. This time I chose the left side. That means I then need to move my number to the other side, plus 7. So I get 9y equals 9. And if I divide both sides, so I'm going to divide both sides by 9, I get y equals 1. Now we have to be careful, and I'm not boxing this because this isn't the answer. Not what is the solution. In this case, the solution did end up being 1, which is kind of funny that we got 1 as the answer, and there is only one solution. But the answer to this one is now there's one solution, and you can see we just got one number as the answer. We know that y has to be 1. That's the only thing it could be. So that's why there's just one answer. There's just one solution. Again, just for reference, we had different y's on two sides, and that gave us one solution. If we have same y's on two sides, things get a little bit complicated because then you have to go to the numbers. If the numbers are the same, so same numbers, then we have infinite solutions. If we have different numbers, we have no solutions. All right. And again, if I wanted to write something that was similar to this, that would have infinite solutions. We could have maybe 6y minus 7 will equal 6y minus 7. So it would have to be exactly the same after we combine all of our like terms. If I want to see something with no solution when we combine like terms, oops, I'll use a different color. It would be 6y minus 7 equals 6y, well, let's say plus 7, because negative 7 and positive 7 are not the same. So that would give us no solutions. All right. Moving on to number 9. So number 9, we got a big equation. So this one looks like it's a little bit difficult. It says find the value of f in this equation. Well, there's a lot of fractions. So we got two options, just like with a lot of the other ones we solved. First option, we could go ahead and distribute. So if people kind of run through the motions and distribute, we're going to distribute that 1/16. So we get 3/8 f plus 1/2 equals 6/16 f minus 3/16. All right. Well, plan is we got to get all the letters on one side, numbers on the other. So let's move one of these f's. Since I did it to the left side last time, I'm going to do that again. So I'm going to do minus 6/16 f on both sides. Now, I kind of know what that is, but just in case we want to double check, remember, we're just going to mess with the coefficients. So we want to do 3/8 minus 6/16, and yeah, we get 0. So that means that these two things just cancel each other out. It turns out that even though these don't look like they're the same, they are the same. And they do end up canceling out. So now we're at 1/2 equals negative 3/16. And we have to ask ourselves again, what is going on here? Because 1/2 is definitely not the same as negative 3/16. That's because the answer is no solution. So this one will not work out. So there's no solution to this one because, again, our two numbers are different. Now, like I said, that was one way to do it. The other way to do it, if we restart, I'm going to come over here. 3/8 f plus 1/2 equals 1/16 6f minus 3. We can see that we got 16 as our biggest denominator. So if we multiply everything by 16 to clear the fractions away, 16 times 3/8, that's going to be 16 divided by 8 is 2. 2 times 3 is 6. 16 times 1/2 is 8. 16 and 1/16 end up canceling out, so we get 6f minus 3. And we can see, like we said on the previous one, I've got the same f's, but I've got different numbers. And same f's and different numbers means no solution. So again, I don't need to solve everything out. But again, it's another one that's cool because there's two ways that you could do it. And whichever way you feel more comfortable with is the way you should do it. And we saw some of them multiplying everything out, doing distributive property was a little bit faster. Sometimes jumping right into multiplying and dividing is a little bit faster. Whichever one makes more sense is the way that you should do it. There's no rule. So that's number 9. For 10, 10's kind of fun. We have 6 equations. So we have to pick between Aka, Satana, and Wa. And you have to pick one equation that has infinite solutions and justify why it has infinite solutions. So this word justify, there's a couple things that you can do to justify math. So for some people, justify might just be solving the equation. That's one way to justify is to just solve it out and show me that you've got infinite solutions. You could also do some writing and write the theory. So again, if you know the theory of why something has infinite solutions, same number of the variable, same constant, same number, then that's it. Once you found out that you actually do have that situation, then you're good to go. Part B is basically the same, but it's just one that does not have infinite solutions. So since there's a lot of freedom in this one, I'm actually going to do all of them. So I'm going to classify all of them. Again, you only need to pick one from each category. You don't need to do all of them. Just in case you picked them, so just so you can see everything out. So for the first one, I'm thinking since this is a decimal, I could turn it into a fraction and clear all the fractions, but I'm thinking I'm just going to go ahead and distribute it. So I was going to become 0.5t plus 0.25t. 0.25 times 16 is 4, so plus 4 equals 4 plus 0.75t. If I combine these two as like terms, I'm going to get 0.75t plus 4 equals 4 plus 0.75t. And at this point, I would either take my right option and say for we'd have 0.75t on both sides and 4 on both sides. So it has to be infinite solutions. So I could take my writing option. If I don't want to take the writing option, if I want to do the solving option, I do need to keep going. I need to subtract 0.75t from both sides to get 4 equals 4. And now I can then put a little check mark there and say, okay, I'm done there also. So that would be my other option to show, okay, I did get just the number equals itself, so therefore it has to be infinite. All right, let's do the second one then. Let's do ka. For this one, we can just answer right away. It does not have infinite solutions because we can see we have different numbers of x's on both sides. So again, if I want to go to the right step, I would say for ka, we have one side is 3x, one is negative 3x, different x's is one solution. So we know that it does not have infinite solutions because we can see that it's got one solution. If we want to take the solving method, now the solving method, we actually have to continue to solve this. So we would have 3x minus 1 equals 1 minus 3x. I'd have to add 3x to both sides. 6x minus 1 equals 1. I'd have to add 1 to both sides. 6x equals 2. Divide both sides by 6 because that's the number with the x. And I would get x equals 1/3. And so here I would show that I have one answer, x is a third, not infinite answers. I don't have just the same thing. So that's what we get for ka. So that's what we got for ka. So next one we got sa. So we got, again, you can just tell 4x and 7x. So again, we can use the same idea here as we did with the ka as we can with the sa. So one side is 4x. One side is, keep forgetting, 7x. And different x's is one solution. So again, if you just want to do the writing, you can just do the quick writing out on that one. If you don't, if you want to justify with the equation solving, you have to solve it. 4x minus 7 equals 7x minus 4. X is on one side. This time I'm going to move it to the right just because there's more x's over here. So negative 7 equals 3x minus 4. I'm going to add 4 to both sides. So negative 3 equals 3x. Divide by the number that's on the x. And I get negative 1 equals x. So one solution. Since I got one answer, can't be infinite. It's got to be one solution. All right, ta's up next. So to do this one, again, I'm thinking distributing is going to be helpful. When we distribute, we get 5x minus 10 equals 5x minus 10. And again, we can see that these are exactly the same. So again, we can do the same thing here. We have 5x on both sides. We have negative 10 on both sides. So we need to have infinite solutions. If you want to go and take the solving method, here, since we've got 5x minus 10, we'd have to do minus 5x both sides to get negative 10 equals negative 10. And once I've shown that all the x's dropped out and I have the number equals itself, it's an identity, so I can then say that's infinite solutions. So if I want to justify, that's where I have to get to if I'm going to do the equations. The next one, same deal. We probably want to distribute that. So we get 3x plus 6 equals 3x plus 3. And again, I know right now is going to come down here. Now, the reason that that's going to come down here, if I want to do my writing, this is a little different because this time they're the same. They're both 3x. So I got 3x and 3x. So both sides 3x, but different numbers. One's a 6 and one's a 3. So in this case, this is a no solution question. So when you have the x's the same but the numbers are different, it's no solutions. If you want to keep going, we got 3x plus 6, 3x plus 3. We subtract 3x from both sides, and then we prove verifiably that 6 is not the same as 3. So that would show that it's not infinite solutions, it's a no solutions. So you could get to here, and then that would be the end. All right, we still got one more. So we got the hop. So for this one, again, it looks like distributing is going to be the way to go. So 2.5 times 2 is 5z. 2.5 times 5 is 7.5. 5 times z is 5z. 5 times 2.5 is 7.5. And so we can see we're in the same situation we had over here. So that's a good one. And then we got 5t and 5t are the same. So 5t on both sides. And then my numbers are 7.5 on both sides. So we must be infinite solutions. If we want to continue to solve it out, again, we have to get rid of the letters. So we're going to do minus 5z both sides. 7.5 is in fact the same as 7.5. So we can stop right there once we show that those two numbers are the same. So long question, but again, I basically did the question 3 times because you only need to pick one from each. So your answer could be, I don't know, ah and na, or this blue one ta and the green sa. You pick one of each. So you only have to really do 2 of them. You don't have to do all 6 once you find one that works. So the cool thing about this question is it's really fast if you got an eagle eye. If you can spot some of them really fast and classify them, then you can kind of get rid of them because you've already used one. So like if you can see that this is 3 and -3, you can kind of spot that this sa right here with the 4 and 7, those are kind of the same. So you wouldn't do both of those. You'd only pick one of them. So I like that question. That's a fun one. But that also means there's only one left to do. So let me put the answers back up there real quick again. All right, so there's only one left to do. It's just number 11. Number 11, Movie Club charges a one-time membership fee of $25. Then you can purchase your movies for $7 each. Another is no fee and sells for $12 each. How many movies do you have to purchase for the total to be equal? Now, this one's unique because if you remember, some of the other questions required you to do an equation. This one does not require you to do an equation, so you are allowed to do any method that you want. So making a nice little chart and being like, okay, what's the price at 1 movie and then 2 and then 3 and then so on until you find out that where they're the same, perfectly acceptable. You want to make a graph? Go for it. You want to guess and check? I mean, you can. You know the number of movies is going to be an integer, so you've got a good idea as to what types of numbers to guess. But if you do want to do the equation is kind of the typical way to do it. So in this case, we got a one-time membership fee of $25. That's like a flat fee. And we're buying movies for $7 each. That's a per charge. That's like a slope. So if you remember from last year, if you want to set this up, this one would be like 7x plus 25 would be the first one. Since we want these two things to be equal, I'm just going to set them to be equal right away instead of doing y equals 7x plus 25 and y equals the next equation. But you could. Then you could do substitution. You could do elimination. You could graph it, whatever you want to do. But for the other one, there's no membership fee, and we sell movies for $12 each. This is going to be $12 per movie plus 0 membership fee. I don't need to write the 0, but I'm making it consistent with the first part. So we need to get x's on one side. I think it's going to be easier, again, to move the smaller number of x's, so I can just subtract. So 25 equals 5x. Remember, if I'm adding 0, I don't need to do anything with that. Divide both sides by 5, and I'm pretty sure I'm done. 5 equals x. And that's it. That's all we got to do. Again, like I said, there's a couple other ways to do it. If you really wanted to do something a little bit different, a chart would be nice. So for 0 movies, we've got Club 1. We got Club 2. And then over here, we would want to have like M for the number of movies. So 0, 1, 2, 3, 4, 5, since we know we're going to get there. We're going to ignore 0. We're not actually going to ignore 0. I take that back. Because for Club 1, if I don't want to get any movies, I still have to pay my $25 fee. For one movie, I got 25, and then I got to pay another 7. So 25 plus 7 would be 32. And then I got to add 7 again to get to 39. And this looks a lot like those tables you probably did last year. Then we add 7 again to get to 46. And we add 7 again to get to 53. And then we add 7 again to get to 60. Now, since I kind of know that's going to be the answer, I'm just going to stop there and do the other club. For the other club, if I don't want to rent any movies, I don't pay anything because I didn't even bother with them. But then if I want to rent one movie, it's $12. So it's still cheaper to do Club 2. And then I got to pay another 12. So then we're at 24. And then we're at 36. And then with the fourth movie, I'm at 48. And then right here, I'm equal at 60. So again, there we go. So kind of cool. So you don't have to use the equation. Again, you could also try guess and check. Let's say you guess 10 right away. You'd see this is 70 plus 25 is 95. This would be 120. So for 10, you know that the green one is too much. So 10 is going to be probably too much because if you pick 0, the black one is 25, the green is 0. So you know it's got to be somewhere between 10 and 0. So you just kind of guess and check until you get to the end. And that's it. So kind of cool. Yeah. So if this doesn't mean like it makes much sense, actually my poster that's in the back, not only did I take that picture, but I did an online service, and I did join the membership fee for this one. I paid the membership fee, which is like $4 a month. And whenever I want to get any of those posters, for me, they cost 30% less. So like I don't have to pay as much if I want to get another one of those. It's kind of interesting that like right in the background is like this problem. I had to actually do the math to find out if I should join the club or not. I figured I would join it. So that was my choice. But yeah, so kind of cool. So yeah, there we go. That's all of quiz 1.